Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. In this video, I'm going to show you how to do gas pipe sizing using the longest length method. This is a simple example coming from Section 402 of the International Fuel Gas Code. However, if you really want to understand this, you're going to need to know more than I'm going to show you in this video. This is just basic. Make sure to watch the entire video that I have on Section 402 for a thorough understanding of how this works. Also, I'm not responsible for any mistakes you make when you size gas pipe, so you make sure you understand this, make sure you do it right, and we're all going to be okay. Enjoy the video. That brings us to the most useful, the most reliable, and probably the simplest of all pipe sizing methods in 402.4.1, which is the longest length method. The size on this is determined by using the longest length of the pipe from the point of delivery to the most remote outlet. So we just look at what's the distance from the meter to the appliance that's farthest away. That distance is going to be what we use. This really simplifies things. Here's a diagram that we're going to size from. This is a basic residential system. And if you look at this illustration, you'll notice we have the meter up at the top in the left. And then we have a number of appliances connected to that, including a furnace, a tankless water heater, a wall heater, and a range. The range is the furthest distance from the meter, and therefore we are going to pay close attention to the distance between those and use that as our longest length to size out on these tables. All right, now let me give you a basic step-by-step on how to use the longest length method. These steps are not listed out in the code, but this is just what I'd recommend as you go through this process and size everything out. Number one, you're going to find the maximum BTU per hour for all the appliances. Number two, you're going to find the section lengths, the different pieces, and the distances. Those you'll be able to size later. Number three, you'll need to find the developed length for the system. We just looked at that. Number four, you can then calculate the cubic feet per hour. Number five, you'll select the correct table for use in that sizing situation. And number six, you can use the table to size out the pipes in that system. Let's go through this. For number one, we're going to find the maximum BTUs for all the appliances. We're going off that same diagram we just looked at. Here's the appliances listed and their BTUs per hour. We have a furnace at 66,000, tankless water heater at 150,000, wall heater at 15,000, and a range at 40,000. The second step, we need to find the pipe section lengths. That might be on a plan that we can scale out. That might be something that we go and we're measuring on site. But here's what we have from the meter to the furnace or mechanical room. We've got 25 feet. There's a branch that goes another 15 feet from the mechanical room, and then it branches off for the wall heater, 20 feet, and the range, 20 feet. Let's look at the third step. Calculate the cubic feet per hour for all of the pipe sections and appliances. I recommend that we put this on a table. And you saw that earlier. I had a table with the appliances and the BTU per hour. I'm just going to expand this. You can do this on a sheet of paper. However you do this, you should keep the information organized as you calculate, so you can always look back and make sure that you know what you're doing. So here we have it on a table. I've got the furnace listed, the BTU per hour. We are going to divide by 1,000 BTU per cubic foot. We're going to be at sea level, so we'll divide by 1,000. That gives us 66 cubic feet per hour for the furnace. Similarly, we have tankless water heater is going to calculate out to 150 cubic feet per hour. Wall heater, 15 cubic feet per hour, and the range, 40 cubic feet per hour. Now, I can total all of those, and that gives me 271 cubic feet per hour, and that's going to be my total load, the cumulative requirements of all of the appliances connected. And that's what I'll use to size the main pipe coming into the building. Now, it's important that we have some other information about the system in order to size properly. So, system information here. Let's say that the inlet pressure is 5-inch water column. That's going to be what's delivered. We're using Schedule 40 steel pipe. This is a natural gas system with a specific gravity of 0.60. I've made some other improvements on our drawing here. And I do encourage you to draw out the system because it's helpful, again, in keeping the information that you need in order to properly size. So I have the drawing, I have the appliances, I have the pipelines, and I've sectioned those out with A is the main line coming in. B is another section of that main line this distributing out. So that's going to go on and feed beyond the mechanical room. C is the line specific to the furnace. D, specific to the water heater. E is going to the wall heater, and F is going to the range. So now I have all of these spelled out, each section, and I need to size each one of these sections so that I know exactly what size of pipe to bring to each one. That is enough information to enable me to go to step 4 and select the correct sizing table. There are many tables in section 402, and the way that we size that is based on the information from the system that we have. First of all, look at what type of pipe. We know that this one is a Schedule 40 metallic pipe, so we'll look on those tables. Then we narrow it down by looking at the type of gas. We've got natural gas, and the pressures, less than 2 psi. So if I was at 5-inch water column, that's less than 2 psi, and specific gravity 0.6. That information is what can help me narrow down which table to use. Once I know that, I stick to that table for the entire sizing exercise. Let's examine the use of this table really quickly. You'll always start with the developed length on the left column. You'll come across to the middle through, that's all of the cubic feet per hour, and then you'll move up to the top and find your gas pipe size. So again, all those numbers that you see, aside from the far left column below, are cubic feet per hour, and your pipe sizes are listed across the top in those columns. So we've taken time to label the sections. We're ready to size this out. I'm going to expand my table a little bit more and have my sections listed down the left side. So A, B, C, D, E, and F. Now for that reason, I would suggest you draw it first, figure out your sections, then make your table, and that way you're not having to redraw your table every time, right? But this is a good model right here. I think we're down to what you need in order to size. You've got your sections listed on the left, appliances, BTUs per hour. You bring it over to your cubic feet per hour, and now we're ready to fill in our pipe sizes. Okay, from here we're going to be back and forth a bit on tables. Look at the top. Let's start with A, the total load for the building, 271 cubic feet per hour. Now, when I go to this sizing table, I know that I'm 60 feet in developed length. So I am going to use this row, 60 feet, for the entire time that I'm sizing. That's the longest length method. We get in there, find that row, and just stick to it. So now that I know which row to use, I come across with my 271. From left to right, it's more than 65. It's more than 137. It's more than 257 by a little bit. So the next one over is 528. That one is greater than the amount of cubic feet per hour that I need, so I can stay in that column. You'll always look for greater than or equal to. You cannot size with less than. So again, that 257, that's not enough. I'm going to go to the next one. 528, follow that up to the top, and I've got 1 1/4 inch pipe. I'll put that on my table. Section A, the main line coming into everything, 1 1/4 inch. Let's skip down past the mechanical room on that drawing, and let's look at the branch that's going to go to the wall heater and the range. We had 55 cubic feet per hour. I'm going to take that line 60 across the bottom. 55 is less than 65. So I can go straight up to the top, and I know I have a 1/2 inch pipe. I'll put that on my table. The branch B going over is 1/2 inch pipe. Let's examine the furnace. The furnace has 66 cubic feet per hour. If I go to line 60, that's more than 65, but it's less than 137, so I'm going to go up in that column, and I find 3/4 inch pipe. I'll put that on my table. Furnace is going to need a 3/4 inch pipe. What about D, the tankless water heater? 150 cubic feet per hour. Following that across, that's more than 65. That's more than 137. It's less than 257, so I can stay in this column, go to the top, and I've got a 1 inch pipe. I'll put that on my table. Tankless water heater is going to receive a 1 inch pipe all the way to the unit. All right, wall heater, 15. Taking that one across, I'm on my bottom line, 60 feet developed length. That's less than 65. Coming up to the top of that column, I've got 1/2 inch pipe. kind of to be expected. And the range, 40 cubic feet per hour, same thing. I go to that line 60, come over, that's less than 65 cubic feet per hour, come up to the top, and I have 1/2 inch pipe. Put that on my table, and look at this. I have a completed table, a full system. I know the pipe sizes for every section and for every branch in that system. I could put that on my drawing, right? A is 1 1/4, B was 1/2 inch, C is 3/4, D is 1 inch, E was 1/2 inch, and F is 1/2 inch. Now I have it sorted out. Now I'm ready to get to work. And by the way, now I can look at this and create a parts list, right? I can look here and go, okay, I'm going to need 1 1/4 inch 90s. I'm going to need some 1 1/4 inch pipe, 1 1/4 by 3/4 T, and so on, right? I can go figure this whole thing out. Now, another important use for this, for the sake of the customer, for the sake of the owner of the building, you should leave either this table fully filled out somewhere where they can have it, say it's with their owner's manual by the furnace or with water heater or whatever, or leave them the drawing, the same thing with all the sizes and BTUs. You want to leave a record of your calculations. So if there's any questions, or later if they want to make changes to the system, they have a really good starting point. They understand exactly what the calculations were, and they can move forward from there. That is a wonderful thing that you can do as someone who sizes, calculates, and installs these systems.